All right, today we're pulling back the curtain on AI. And you know what? We're going to treat it like a recipe. We'll break down the exact steps you need to go from just an idea to a working AI. I mean, have you ever looked at your smart assistant or maybe a recommendation on a streaming service and just thought, how? How does an idea just floating around in someone's head actually become a real piece of smart tech? Well, here's the good news. It's not magic. Not at all. It's actually a step-by-step process, a logical cycle that developers follow to build, test, and get these systems out into the world. And today, we're going to walk through it together. Okay, let's dive right in. What you're looking at here, this is our roadmap. It's called the AI project cycle, and it lays out the entire journey from spotting a problem to grabbing the data, building the model, and then, of course, checking if it even works. So let's start right at the beginning, shall we? So every great recipe starts with one thing, right? Knowing what you actually want to cook. In the AI world, we call this first step problem scoping and data acquisition. Basically, it's where you figure out your goal, and then you go gather your ingredients. And to get started, there's this really simple but super powerful tool called the 4Ws Canvas. It makes you ask the big questions. Who is this for? What exactly is the problem we're trying to solve? Where is this all happening? And maybe most importantly, why? Why are we even doing this? Answering all of that leads you to something called a problem statement. And this is not some vague, fuzzy idea. It's a super clear goal. So instead of saying something like, let's predict salaries, a good problem statement would be something like, let's predict an employee's next salary based on their past history to help them with financial planning. See? So much clearer. Okay, so you know what you're making. Now you need the ingredients. In an AI, the ingredients are data. There are two golden rules here. The data has to be relevant to your problem, and it has to be authentic. Accurate and trustworthy. Because let's be honest, bad ingredients make for a bad meal. Doesn't matter how good the chef is. And listen, these ingredients can come from everywhere. We're talking about surveys, stuff scraped from websites, data from sensors on a factory floor, pictures from cameras, pretty much any little piece of information you can collect that will help the AI learn. All right, recipes picked, ingredients are on the counter. Now it's time for the actual cooking. This is where we choose and build the AI model. This is the part where we turn all that raw data into something, well, intelligent. So there are really two main cooking styles for AI. First, you've got rule-based AI. This is like following a cookbook to the letter. If this, then that. Like if a patient has a fever and a cough, then suggest a flu test. Super direct, but also very rigid. But then you have learning-based AI. This is more like a seasoned chef who just knows. They learn from the ingredients themselves, figuring out patterns on their own. And that is where almost all modern AI is headed. So let's talk about that learning-based style. A really common method is called supervised learning. Think of it like this. You're showing the AI flashcards. You feed it a ton of labeled data, pictures of fruit that are clearly tagged apple or strawberry. The AI studies them, learns what makes an apple, and then when you show it a new picture, it can classify it correctly. It's literally learning from examples you've provided. Okay, but what if your data is a total mess? No neat labels. That's where unsupervised learning comes in. You just dump a mountain of data on the AI, let's say a bunch of customer buying habits, and you tell it, go figure it out. It has to find the patterns all on its own. It might discover, hey, there's a group of people who only shop late at night, or here's a cluster of weekend bargain hunters. It finds these groups without you ever telling it what to look for. And that brings us to the real powerhouse behind the most advanced AI today, deep learning. This stuff uses something called an artificial neural network, which is a system kind of inspired by the neural connections in our own brains. And the main thing you need to know is this. The more data you feed it, the smarter it gets. It's that simple. So, how does one of these things actually work? Well, you can think of it in three basic stages. First, the input layer. It just takes in the raw data, like all the pixels in a photo. Then you have the hidden layers. This is where the magic happens, all the heavy lifting and complex processing to find patterns. And finally, the output layer spits out the answer. Something simple, like bird. So the meal is cooked. The model is built. But is it any good? Time for the taste test. In AI, we call this evaluation. This is the moment of truth, where you find out if your recipe was actually a success. A classic tool for this is something called a confusion matrix. It sounds complicated, but just think of it as a scorecard. Let's take a spam filter, for example. The scorecard shows us exactly where it got things right and where it messed up. So, it correctly nailed 8 spam emails, that's a true positive, and it correctly identified 7 normal emails, a true negative. But as you can see, it also made some mistakes. So, what's the bottom line? This is where we calculate the model's accuracy. We just add up all the correct guesses, so the 8 true positives plus the 7 true negatives, that's 15. Then we divide that by the total number of emails, which was 20, and boom, we get an accuracy of 75%. That's usually the first number everybody looks at. But wait a minute, is 75% actually good? Well, it depends, right? Look back at that scorecard. The model let 3 spam emails slip through. Annoying, but whatever. But look at the other mistake. It marked 2 real emails as spam. Now, what if one of those was a job offer or a critical alert from your bank? All of a sudden, 75% accuracy doesn't sound so hot, does it? It just goes to show you accuracy isn't the whole story. And that brings us to our final and maybe the most important step in the whole recipe. I like to call this the allergy check. It's not just about whether the food tastes good, it's about making sure it's safe and fair for everyone who's going to eat it. This, right here, is the crucial role of ethics in AI. And here's the absolute core truth of AI ethics. You ready? An AI is only as good as its ingredients. If your data, your ingredients, are full of historical biases, guess what? Your final AI is going to serve up those exact same biases. It's really that simple. And that's what makes it so dangerous. Let me give you a real-world and honestly kinda scary example. There was an algorithm built to figure out which patients were high risk and needed extra medical attention. Now, to do this, it used a shortcut. It looked at how much money a person had spent on healthcare in the past as a way to guess how sick they were. The logic seemed, well, logical. Sicker people spend more money, right? But the result was a complete disaster. It started flagging patients from poorer communities, people with less access to care, as healthier simply because they hadn't spent as much money. The outcome here was just stark. The study on this said, and I'm quoting here, the algorithm actively harmed patients by misallocating resources. So this AI wasn't just wrong. It was actively making existing inequalities even worse by preventing the people who needed care the most from getting it. And that really is the biggest lesson from this whole recipe. Building AI isn't just a technical challenge. It's not just about code and data. It's a deeply human one. It forces us to think really hard about fairness, about bias, and about our own responsibilities as the people building this stuff. So, as these AI systems get woven deeper and deeper into our world, making decisions about our health, our jobs, our money, the big question we all have to ask ourselves is this: how do we make sure the AI we build reflects the best of us and not the worst of our history?